Welcome everyone. Our project is about analysis for internal airflow in residential building using ANSYS Fluent. We are doing this project under the guidance of Dr. Vigneswaran, and my project mates are MJ Vishal, K. Vishal, and Open Kumar. Heating, ventilation, cooling, air conditioning systems. These are the integral part of the building, which is mainly used in heating and cooling of the building. These heating and cooling requires a lot of energy, which are being used extensively in this field. We are doing this project to reduce this energy consumption and improve the air quality in the building. Problem statement: high amount of resources and materials are being used for cooling and heating of the buildings. Not every given resource is used in the fullest extent, as they are using this cooling and heating mechanisms in an extensive way, but not providing adequate energy. Many essential buildings face challenges with inadequate airflow and resulting in poor air quality index. By fixing these problems, we can increase the indoor air quality. Current design practices does not rely on geometries, occupancy patterns, and varying external environmental conditions. These need to be addressed to improve the air quality in the building and reduction of uh, energy consumption. These are the various things we are studied. Overall energy efficiency in the building and system optimization are being done. Thermal comfort methods such as PMV and adaptive comfort methods are used in the building for cooling of the building. Indoor air quality reduction due to the formation of various water sacs and repeated air flow. Smart adaptive technologies such as artificial intelligence or smart technologies are being used in this field. Our scope is to analyze and optimize the internal airflow in the building. Data collection through various inputs, a model development for providing air flow in the building, optimize the strategies such as improvement of the air efficiency, deliver a well-rounded plan to as an optimized building model. Our product objective is to analyze the heating, cooling, air conditioning system in the building as of a main building plan, to control the climate within the building by providing various vents and to optimize the comfort generated by following methods are to be employed either to active or passive cooling methods. We are mainly focusing on passive cooling methods such as using vents and windows. Our methodology is modeling a building in AutoCAD and converting it to an IGS format to provide and feed it to ANSYS Fluent. Select a representative model. Use these models to modify the building plan. Create a 3D models in the ANSYS and providing airflows and wind patterns. Identify critical features such as thermal contours which shows high temperatures in it. Formulate actionable strategies such as providing various models which can decrease temperature and airflow control.
Hi, this is the plan of our project. In this slide we have shared elevation, section, plan and the site location. This is the plan of our building. The residential building we took for the analysis. Here we shared the hall, kitchen, toilet, 2 bedroom. This is the elevation of our building. It is contained at A dash. This is the section of our building. We have cut in A dash direction. We have given the details about the windows. This is the site and location plan. Our site is located in Madurai. The wind direction is in northeast 45 degree. This is the ANSYS workflow. We have taken the geometry of the building and then meshed, and the result is formed. This is the model of our building in ANSYS. There are 5 rooms. This is the ANSYS model after meshing. Velocity of air is 2.5 meter per second. Temperature 24 degree Celsius. Direction northeast 45 degree. This is the ANSYS model for optimized building. Heat flux is 100. Thermal conductivity 0.9. Thickness 230 mm. Number of windows 10. Number of winds 2.
So here we are at the test results. Let me explain every test results individually. You can see this is the temperature counter of the simulation of the residential building we have designed. This is for a 2.8 meter ceiling height. This is for a 3 meter ceiling height, which we have done with and without vents. In the tabular column, we have explained it very clearly. So this is the velocity and streamline diagram and the pressure diagram. You can see the detail in colors and differential temperatures. Let me explain this on the tabular column. So for easy understanding, we have designed a graph which you can see there. This is the normal house which has a 28 degrees Celsius, and this is a 2 meter ceiling height, 2.8 meter ceiling height with a difference of 1 degree, and it reduces eventually, which 3.2 meter better performance, has a better performance. And in the next slide you can see the difference detail. So as you can see, this is the temperature tabulation, average temperature tabulation. You can see this here, the wall to window ratio from 12% to we have increased the wall to window ratio as 20%, and we have changed the without window and vents. And with window and vents, you can see the temperature as 29 degrees Celsius, close to 29 degrees Celsius, which has a 20% thermal loss. Our project is to reduce the thermal loss for a residential building, which we have reduced to 26.6, close to 26.6, which is good. Eventually, I am going to the next slide. So as you can see, this is the result conclusion. The left side is the problem occurred in the original plan, and the problems are corrected in the right side. The main problems is the recirculation of air, increase in negative pressure, increase in temperature, reduce in velocity, which we have corrected using 8 different plans. We reduced the temperature and increased the velocity inside the house by giving the optimum design and temperature for the climate. So this is our project which helps in increasing the efficiency of a building through the plan design. Thank you.